inviting our next speaker, FrankZou. Frank serves as the Vice President of ARM's infrastructure line of business and is responsible for business and ecosystem development in the Chinese market. He leads the team to continuously innovate ARM IP products and solutions to meet the needs of the Chinese market, from cloud data centers to the edge infrastructures. Before joining ARM, FrankZou was the CTO and the VP of Huawei's Enterprise Business Group in the US. Frank has more than 20 years of industry experience in Silicon Valley and has held positions such as software engineer, platform architect, and product management director at companies like Cisco, Juniper, and EMC. Frank holds a master's degree in electronic engineering from USC and a bachelor's degree in electronic engineering from Peking University in China. The title of his presentation today is Evolvement and Trend in ARM's Cloud Infrastructure Ecosystem. So without further ado, ladies and gentlemen, please help me to welcome FrankZou.
Thank you. Let me bring up my slides. Can you guys see my slide?
Yes, very clear.
All right.
Thanks.
So good afternoon, everyone. This is FrankZou from ARM. I'm the VP of the go-to-market at ARM's infrastructure line of business. Today, I'm very happy to have this opportunity to attend CASPA2022 2022 and share some of my thoughts about the mega trend in the semiconductor industry, especially in the cloud 5G infrastructure space. AI, 5G, and the Internet of Things are all maturing at the same time to create a new computing landscape we like to call the fifth wave of computing. It will fundamentally change the world we live in and enable great efficiency and a more sustainable world. If we consider the vast amount of IoT endpoints that now outnumber the number of people in the world, these devices need a global network with AI-enabled compute capability woven seamlessly. We see devices like IoT gateways, edge compute servers, and even 5G networks becoming smarter and adding more compute resource at the edge of network. ARM is powering these next generation infrastructure designs by providing the IP necessary to scale compute costs from tens of cores in a gateway to thousands of cores in data center rack. Also, cloud native software and technologies like virtual machines and containers, which can run natively on ARM 64-bit architecture, are also being adopted throughout this infrastructure, bringing a new level of compatibility across the whole ecosystem. Here is some data from the Synergy Research Group I would like to share with you. It shows that Q4 2021 enterprise spending on cloud infrastructure service passed $50 billion mark, up 36% from the fourth quarter of 2020. Total year spending reached around $178 billion, up 37% from the year of 2020. Amazon continued to lead the market with its worldwide market share staying almost constant around 33%. In the meanwhile, Microsoft continues its market share growing by almost 9% points since the end of 2017, reaching 21% in the fourth quarter of 2021. Google and Alibaba also continue to grow market share, while in aggregate, the long tail of small to medium small to medium-sized cloud providers see revenue growing steadily, but market shares declining. On the right side of the slide, the diagram shows the growth of infrastructure spending. We can see actually telco capex level up to the first half of 2021 were once again flat, while the hyperscaler operator capex shoot up by another 30%. Meanwhile, enterprise spending on IT infrastructure recovered a little bit and grew by 6%. These numbers reflect the longer term trends, which show that telco capex has essentially been static for the last 6 years, while hyperscaler operator spending has almost tripled, and enterprise IT infrastructure spending has grown by 23% as well. So the total infrastructure spending in the first half passed $300 billion mark, with hyperscaler operator growth accounting for 27%, up almost from just 30% in 2016. We can see it's just 13%. So ARM is the world's leading semiconductor IP supplier with more than 600 silicon partners. And our partners combine ARM IP with their own IP to create complete chip designs. Our technologies secure power products from the smallest sensor to the most of the world's smartphone and even the world's most powerful supercomputer. Our energy efficient processor designs and software platforms has enabled advanced computing in 200 billion chips shipped since ARM's inception in 1990. And also the pace of the shipment is accelerating, as last year alone, over 23 billion chips shipped with ARM-enabled technology. Together with our ecosystem of technology partners, we are at the forefront of designing, securing, and managing all areas of connected compute, from the chips to the cloud. ARM Neoverse is a modern cloud-to-edge infrastructure foundation for a world of 1 trillion intelligent devices. ARM Neoverse is a dedicated roadmap and the new brand of infrastructure class IP for 5G networks and the next generation cloud to edge. And ARM Neoverse solutions are also uniquely designed for the higher levels of performance, security, and scalability not seen today. Innovation from microarchitecture design up through silicon, software, and system will enable best-in-class solutions to address the diverse and evolving requirements across the entire compute spectrum. And also the rich diversity of hardware and software solutions that have come to market enabled by Neoverse-based compute are now deployed in the cloud data center, HPC systems, 5G networks, and out to the edge gateways, providing cost savings, power efficiency, and compute performance gains. Back in September, when we introduced our newest Neoverse N2 and Neoverse V1 platform to our roadmap, it was a testament to the groundswell of Neoverse interest and adoption across our ecosystem. Today, I'm pleased to share some growing list of ARM partners bring the superior performance per watt, and the TCO benefits of Neoverse to the infrastructure markets. A couple of examples milestones in 2021 we achieved. For example, Marvell actually revealed its Octane family of networking solution based on Neoverse N2, and it will begin sampling by end of 2021, providing 3x performance uplift over previous generation of Octane solutions. And also Oracle plans to adopt Ampere Ultra CPUs for Oracle Cloud Infrastructure as a price performance leader across a wide range of workloads. ARM-powered AWS Graviton 2 continues to rapidly expand its EC2 footprint with steady growth and regional expansion. Look back to the in China market, Alibaba Cloud just tested the upcoming Alibaba Cloud ECS ARM instance, showing off impressive results on the Spec JBB benchmark, with Spec JBB, which is a Java benchmark, and it shows improved performance of the Dragonwheel JDK on ARM by almost 50%. Tencent is also making investments in both hardware testing and on software enablement that will allow them to adopt Neoverse technology for cloud applications. So it's not the news to all of us. AWS has been leading the charter when it comes to adopting ARM Neoverse for their infrastructure through the Graviton and the Nitro. They have come a long way in their effort to optimize and offer more and more EC2 services on Graviton 2 while enabling wider variety of workloads on them. Based on a popular analyst literature, of all the EC2 instance types added in calendar year 2020 by AWS, around 50% of them are based on ARM-based Graviton 2. And while the x86 make up the remaining half, which is pretty impressive. In December 2021, AWS also achieved its next ARM technology milestone with AWS Graviton 3, which delivers 25% more performance for compute-intensive workloads. Additionally, Graviton 3 achieves up to 2x floating point performance on machine learning, gaming, and media encoding workloads, and up to 2x faster performance on cryptographic workloads. Graviton 3 also supports the bfloat 16 data to deliver 3x better performance for machine learning workloads. And all of this are achieved while using up to 60% less energy. Even more, AWS reviewed C7G instance powered by new Graviton 3 processors, and these are available in preview stage right now. C7G is the first cloud instance to support DDR5 enabled by ARM Neoverse platform to allow for more memory bandwidth and unlock even more performance. Customers like Twitter are already testing C7G instance in beta and seeing almost 20 to 80% of higher performance over C6G instance. Back in the China market, at the Hyperscaler conference 2021, which is an annual cloud service technology forum hosted by Alibaba Cloud, it announced an ARM-based server processor E10710, developed by Alibaba's in-house semiconductor unit, T-Head. The E10710 was built for custom by T-Head. It has 128 ARM cores. In addition, it also features 3.2 gigahertz fast clock speed. Each processor inside it contains 60 billion transistors, as well as a 96-lane PCIe 5.0, and even eight DDR5 channels. E10710 was the first processor, Alibaba's first processor to have an ARM v9 compatibility processor. The data center would benefit from this development. According to Alibaba, the chip would be utilized to extend cloud service support for customers in the near future. Besides success at AWS, there are numbers of US and China hyperscalers who have publicly announced their intentions to deploy ARM Neoverse-based Ampere Ultra servers. Some of the noteworthy ones, including Oracle Cloud, which I mentioned just in the previous slides, and also Micro Azure, Tencent Cloud, Cloudflare, and Binance. The way Ampere has been positioning themselves for their Ultra platform is for anyone who wants to deploy Graviton 2 type of compute capability on their premise data center. Also, a dedicated processor optimized for some certain tasks creates an opportunity for the customer to better focus their CPU cycles toward paying workloads instead of the infrastructure tasks, yielding TCO benefits in power and CapEx. Here comes with the DPUs. Some notable announcements included in this slide for DPU update. In July 2021, Marvell announced its Octane 10 family of DPUs built with ARM Neoverse N2 and TSMC 5nm process. Octane 10 promised to deliver 3x more performance and 4x performance per watt. And recently, also we see actually Intel announced its IPO codename Mountain Evans with the leading US-based cloud service provider, which is Google. It combines 16 ARM Neoverse N1 processors and other accelerators into a single chip, DPU chip. And also NVIDIA, in the meanwhile, announced that its Bluefield 3 DPU containing its Mellanox technology and 16 ARM Cortex-A78 processors will be able to replace 300 traditional processor cores. Samples are expected in the first quarter of 2022, and later, Bluefield 4 will double bandwidth to 800 gig bps. And also we see actually VMware, Dell, Passenger Systems, Palo Alto Networks, Chronicles, Supermicro, NetApp, and others have launched products or initiatives to take more advantage of DPUs. Let's look at the HPC market. So HPC market is expanding with new type of work, adding AI and data analytics to those traditional simulation and modeling. ARM is a driving force behind many of the new Exascale-Class CPUs that will power tomorrow's supercomputers. Let me first highlight Fujitsu's A64FX processor that powers the Fugaku supercomputer at the Riken Center for Computation Science in Japan. Fugaku made its debut and became the fastest supercomputer in the world ever since June 2020, as well as becoming the first ARM architecture-based computer to achieve this. Basically, it achieved 1.442 exaflops in HPL AI benchmark, making it the first ever supercomputer, and it still maintains this top rank actually today. They also maintain this top one even in 2021. And also European Cypher has developed its own Neoverse V1-based SoC, which features substantial HBM3 memory, along with DDR, and enable other EU accelerators in the future. And the ETRI is a national research institute in South Korea. It's developing an ARM-based CPU for their future supercomputer. It will support both double and mixed precision math to tackle HPC and AI applications. Finally, NVIDIA, coming to the market in 2023 with their Grace CPU built with ARM Neoverse IP. According to NVIDIA, It's expected to deliver 10x the performance of today's fastest server on the most complex AI and high-performance computing workloads. They also announced 2 large-scale HPC design wins at Los Alamos and also the Swiss National Supercomputing Centers. That's a big win for ARM ecosystem as well. Let's look at the 5G market. We see 5G momentum and developments accelerating rapidly. Developments and time to market from the specifications is much quicker than we saw previously, with 2G to 3G and then from 3G to 4G. The rate of deployment is probably double what we expected and has somewhat taken the industry by surprise. Also, ARM's challenge in continuing to support the rollout of 5G is how we can help define and support scalable platform needs. Looking at some of the market size and some of our position in this market, cloud data center is the largest market. But for the traditional cellular equipment path, the radio access network is the largest, significantly larger than the core. ARM has a significant market share in the RAN, probably around 80% or higher today, largely because of our close relationship with those tier 1 networking OEMs and their silicon providers like Marvell, Broadcom, and Xilinx. ARM has also now joined many of the open initiatives like the Open RAN, right? O-RAN Alliance, and also FBTIP. And it will be interesting to see how quickly this market share grows for the open platform equipment. The 5G supply chain is constantly evolving, and ARM is collaborating across the industry, building a strong ecosystem that meets the various technology needs, but also looking at the various links to facilitate deployment of these technologies. 5G has brought a new set of user cases, which are significantly more complex and has new requirements, such as being cloud native. By generating a wider base of collaborations, ARM's desire is to support these new requirements, support the new stakeholders, and create more choice and diversity in this market. This diagram illustrates how this works. So basically, ARM will provide a silicon framework to provide flexibility in base platforms. Then we're working through silicon partners and into the tier 1 and emerging 5G network OEMs. We recommend the right blend of compute while integrating those accelerators for the L1 processing, machine learning, packet processing, or security into those SoC devices. And together with the ISVs, combine these SoC devices with the software implementations. Next, we'll ensure we are meeting needs of network operators as well, who are asking for more flexible software-defined capabilities through open source software work. This approach allows us to also engage with other stakeholders like cloud and enterprise companies who haven't previously been involved in the cellular market, but now in the 5G market, it's now considered this technology key to their operation as well. So ARM-based technology is the leading choice for building 5G infrastructure. Take off the cover of almost any base station, we actually could find there's a good chance you'll find there's ARM inside. We also believe that ARM ecosystem will be driving force for innovation in the cloudified era. ARM delivers best-in-class compute performance, best-in-class performance per watt, and best-in-class performance per dollar. As a result, technology from our partner can be found across network, powering everything from compute-intensive assets like centralized unit, CU, and radios to energy-efficient small cell unit, providing connection to remote assets. This experience has also allowed our partner to cultivate the expertise for integrating 5G's radio layer with the coming cloudified hardware and software. So this slide basically shows some of the silicon choice in the 5G ecosystem based on ARM. In order to accelerate innovations like those solution and user case that we just talked about, we announced the ARM 5G Solution Lab in October 2021 with the goal of fostering collaborations and innovations. We are partnering with leading telco systems integrator to host the lab, who brings a wealth of expertise in the segments with broad operator relationships and a proven track record running industry certified lab. The lab will provide all the key building blocks, securing remote access to state-of-the-art equipment, end-to-end components from UEs to radios, ARM's ecosystem, hardware, software, etc., lowering the barrier to work together. Across the spectrum, our partner can work on the end-to-end solution in integration, validation of POCs, and benchmarking activities for networking loads. Working closely with those operators will be enabling those blueprints for user cases that would get solution closer to deployment readiness. ARM's vision with Neoverse is about more than just a process IP. It is about delivering a complete infrastructure platform and the element required to enable a robust ecosystem of software, SoCs, systems, and tools for compelling new solutions from the cloud data center to the 5G edge. To further ARM adoption in the infrastructure market, we have been very active in open source communities and various organizations that support the open source projects. We and also our partners are deeply involved in helping further ARM ecosystem support in the cloud data center. Today, we are involved in over 100 open source projects and 25 standards organizations. This work spans operating systems, languages, libraries, tools, virtualization technologies, and workloads heavily focused on the cloud native application space. As we focus on the emergence of new cloud native workloads, being an active member of the cloud native community is also very important. We also see that developers are rapidly adopting cloud native software. We have a significant footprint of the OSS projects. Independent software vendors are already supporting ARM 64-bit architecture. The number of containers images written for ARM is over 100,000 on Docker Hub. And we have over 1 million CI/CD build work stream every month occurring on ARM hardware across a wide array of applications to perform software validations. We are continuously working with partners in the software ecosystem to optimize their application to take advantage of all the performance ARM processor can offer. At ARM, we are working almost every day to ensure that software can easily be being developed and deployed on ARM platforms. We see a future where all of the world share the digital data with, at some point in its lifetime, being processed on ARM. to execute this vision requires significant investment in software and support for developers who write the code. So here's some number I would like to share. Around 40% of ARM engineers support software development in some way. And we also calculate over 10 million developers hours invested by ARM in the first decade of our ARM v8 architecture, which is pretty much past 12 years. As we have recently announced our new ARM v9 architecture, we expect to expand, we also expect to these investment in the software to expand even further, helping to ensure that all the software just works on ARM, right? So this concludes my presentation today, and thanks again for this opportunity to allow me share my thoughts with all of you. Thank you.
Hey, thank you, Frank.
Thank you.
It's truly amazing. You know, all you and your team at ARM, your work. I think it's easier to talk about who is not using the Neoverse and Graviton, right? It would be easier and faster to talk about that list than those who are. You know, you talk about even supercomputer related customers in Japan and now Korea. That's truly impressive. I think you are perhaps in the best position to address this topic. You spend many years in technology leadership here in the US as well as in China. So of course there are a lot of things, that's a lot of synergies between the two, but also there are a lot of differences. What do you see, especially in the cloud infrastructure environment, the hyperscalers in China versus the hyperscalers in US? What do you see are the major differences in their approach, and maybe the pros and cons? Can you share a little bit of what you have seen in both places?
Sure, definitely. So the business unit I'm responsible in ARM is infrastructure line of business, which covers hyperscaler, cloud data center, and 5G networks. And we launched our Neoverse platform in 2018, which is a dedicated roadmap, IP roadmap, and a platform for the hyperscalers or infrastructure product. And after that, actually, we do see very strong momentum for the product or the SoCs chips based on Neoverse, which I just shared in my slides, right? We see AWS, and we see actually AWS launched their own customized server CPU based on Neoverse. And for example, Oracle Cloud Infrastructure is utilizing the Ampere server CPU, which is also based on ARM Neoverse. Microsoft Azure also announced a similar plan, right? So we see actually in the US, we basically refer to rest of world compared to China market. In the rest of the world, we see hyperscaler actually leading the way to utilize the heterogeneous basically computing, right? Basically in their cloud service, they are able to provide a x86-based cloud instance, ARM-based cloud instance. And similarly, actually, we also see the same trend in China market, hyperscaler China market. Maybe with several months, half a year or 1 year lagging behind, but we do see the similar trend in China market. And I just shared in my slides, Alibaba announced their first ever custom server CPU, which is based on ARM architecture, right? Very similar to the strategy AWS is marching toward. And we see Tencent and also ByteDance announced their intention to adopt the Ampere ARM-based server in their cloud service as well. So in summary, we see that very similar trend, but definitely there's some time lagging behind, but we are very confident actually our Neoverse will be successful in those hyperscaler market.
Great. Well, congrats. We look forward to hear more from you and as well as other speakers in our panel discussion.
Thank you.
Thanks again, Frank.